Hi everyone, in this video we're going to talk about series, and I've got an infinite series listed here. It asks us to evaluate the sum as n goes from 1 to infinity of 1 over n squared plus 7. So first of all, let's talk about this notation. The big sigma, this big Greek letter here, sigma, means sum. So S for sum, S for sigma. And it means to add up. So I'm adding up things of the form, terms of the form 1 over n squared plus 7. And the first value we'll work with for n is 1, and then we'll go 2 and 3 and 4, and we'll just keep going. And we're going to march all the way up, heading towards infinity. And we can't ever get there. I cannot physically add up an infinite number of things in my lifetime. So we're going to need to use some analysis here. All right, to get started, let's explore some partial sums. So first of all, instead of working with the infinite sum, suppose I just said to you, okay, work with the sum as n goes from 1 to 2. All right, so what that would be asking you to do, it would be asking you to add up things of the form 1 over n squared. We'll start off n with 1, plus 7, plus the ending value for the n would be 2. So I'd be asking you for this sum. I'd be asking you to add up these two terms. There's one term, and here's the other term. And you tell me what the answer was, right? So we can even ask Maple what the answer is. If I'm in math mode, Maple will tell me that the answer is 19 over 88. And we can ask Maple to give us a decimal approximation. Now we could keep playing this game. We could ask Maple to give us the first 10 terms and add them up. It will take a while. I've gone over and done that. You could keep going. You could take 151 terms. I just chose that number because it was big. And you would find that this sum, the partial sum, is about 0.5157. And you could keep going and playing this game and taking bigger and bigger partial sums. And you would wonder, you know, is this roughly trending towards 0.5 or 0.51, 0.52, something like that? And that's a really good question, and we will answer that in a few moments. So again, exploring the partial sums just gives you a sense of what's happening. You're just adding up terms, and you're adding up more and more terms, but it doesn't really give you the exact answer in terms of convergence and the exact answer in terms of what the sum might actually be. So if you want to figure out if this series converges or diverges, one thing we could use here is the comparison test. We know that this series converges. We have p equals 2, and we've studied that. That's one of the known convergent series, and you can refer to your calculus book for other good series for using the comparison test. So what I observe is that the terms in my series of interest, they are less than or equal to the terms in the known convergent p-series. Therefore, our series that we're interested in, and I'll just replace this with the infinity sign, converges by the comparison test. So we do know that the series converges. We know that if we could possibly add up infinitely many terms, that we would get a value. More precisely, we know that if we take the limit of the partial sums, if we take the limit as this upper value goes to infinity, we will get a value. We can also ask Maple to compute the value of the infinite sum, and if we do that, notice that I've replaced the upper limit here with the infinity sign, and I'm in math mode. Maple gives us the exact expression, and I can also use the eval f to get an approximation, which turns out to be about 0.522.